We usually think the ultimate promise of artificial intelligence is unlimited context, the ability to remember every line of code, every note, and every prompt you've ever given it. But perfect retention has a hidden catch. If an AI remembers absolutely everything, its memory quickly turns into an unmanageable junkyard of information. Anthropic initially tried to solve this with a system for Claude called auto-memory. The foundational purpose of auto-memory was straightforward: retain notes and context across all of your user sessions so you wouldn't have to repeat yourself. But saving every note introduces data entropy. Over time, stored information degrades, leading to memory decay. Debugging steps from Tuesday start contradicting new instructions from Thursday, while vague timestamps make it impossible for the AI to determine which context is actually current. These symptoms paralyzed Claude's ability to maintain accuracy during long-term coding projects. The AI would attempt to follow outdated logic alongside new frameworks, leading to incoherent and unreliable outputs. Long-term AI collaboration fails without an active curation mechanism to stop data collapse before it starts. To fix this data entropy, Anthropic introduced AutoDream. Instead of passively hoarding files, AutoDream acts as an active memory management system. The blueprint for this system comes from biology. Much like how the human brain uses REM sleep to consolidate daily experiences, filtering out the noise and reinforcing what matters, Claude now undergoes a similar process to organize its own memory. This digital sleep cycle triggers automatically in the background. It activates every 24 hours or after 5 sessions. If you're working through an intense problem, you can also force the cycle manually by typing commands like "consolidate my memory" or simply "dream." By programming a dedicated sleep cycle into the model, Anthropic shifted Claude's data management from a static warehouse into a living, self-cleaning ecosystem. This diagram maps exactly how AutoDream processes a messy dataset through a 4-phase algorithmic pipeline. The first phase is orientation. The AI scans all existing memory files and maps out the known information, establishing a clear structural baseline for any updates. Next is gather signal. Here, the system sifts through the noise to isolate high-value data. It specifically looks for firm project decisions, recent corrections, and recurring patterns, prioritizing these over casual chat. The third phase is consolidation. AutoDream cleans the dataset by merging duplicate entries and mathematically resolving contradictory notes, ensuring that old debugging steps don't fight with new solutions. Finally, the system executes prune and index. Outdated and irrelevant data is permanently deleted. This step is necessary to keep the dataset lightweight and optimize the AI's retrieval speed. This highly mechanical filtration process directly solves the memory decay problem. It takes a massive, confusing data dump and converts it into a structured format for rapid insight retrieval. Because AutoDream actively edits and deletes information, it operates within strict boundaries. The system only manipulates isolated memory files. It never executes direct modifications to your actual code or project data. Anthropic also built in a primary defense mechanism, known as the instance lock system. If you are running multiple instances of Claude simultaneously, the instance lock physically prevents the system from writing over itself, avoiding memory conflicts and crashes. By cordoning off the memory files from the operational code, AutoDream maintains a stable environment even during its most aggressive optimization cycles. In the past, interacting with an AI meant dealing with fragmented, isolated episodes. Every time you started a new chat, you had to rebuild the context from scratch. AutoDream connects those isolated sessions into a continuous, uninterrupted project timeline. Constant background pruning gives Claude structured, reusable knowledge. It can actually grasp the constantly evolving architecture of your complex APIs and frameworks across many months of continuous work. Claude maintains a persistent understanding of a project's lifecycle, eliminating the need to rebrief the system at the start of every session. Achieving this unlimited memory in artificial intelligence did not require building massive new server farms or expanding physical hard drives. Artificial intelligence achieves reliable, long-term memory by mastering the ability to forget the noise so it can prioritize what actually matters.